So hi, we will start with a new part of algorithms. Although these things we have seen before. So we have seen some sorting algorithms in unit 2 beforehand, right? But we had not written down the formal algorithms for those because we were not familiar with data structures, arrays, lists, and those kinds of things as much as we should be, right? Because those things will come in unit 3. So we are going back to this topic of unit 2 back, and we will now complete this. Okay, so now we will write down the formal algorithms of all the sorting algorithms that we have seen so far. Okay, so on the left hand side, as usual, I will be writing down the algorithm as before, and on the right hand side, I am just showing you the lecture slides that were for the sorting algorithms that we have seen before. Okay, so parallelly we will compare what we have seen, and then we will write down the appropriate algorithms on the left hand side. Is that okay? So let's start. So the most basic kind of sorting that we have seen was the merge sort, right? That was the first kind of sorting algorithm that we saw. So let's write down the formal algorithm for merge sort. Okay. So sorting algorithms, the first kind that we're going to deal with is merge sort. All right. So let's do a quick recap. I'm not going to explain the whole thing, but let's do a quick recap. So this was not important. So this was the idea, divide and conquer. Given any array, we are dividing it into half, 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 right? We keep on dividing it into halves until a point where we reach something that is very similar to just two elements or single element of that kind, right? And then the sorting becomes more or less trivial, right? But in between, there is a merge step, right? How do we do the merge step? We have seen that. So merge step is again recurring. Okay, so merge step happens like this. We take two arrays of roughly the same size, and then we go on basically comparing first index with first index, second index with second index, and so on. And then that gives us the final merged array. Merged array is of the length equal to the sum of the lengths of the individual two arrays. Okay, and then there was a small exercise to complete this code, and the runtime was n log n. We have seen that before. Okay, all of this we have seen before. So let's go back and let's start writing down the formal code. Let's write down from this part because this part is the more important. Okay. So let's first write down the algorithm to sort to, uh, to given arrays. Okay. So let's write that down. Before we do that, one thing that we should note is that we always do a lot of exchanges, right? In sorting algorithms, as we have seen, one of the fundamental operations that we require is to swap any two uh, elements, right, from the array. So instead of repeating that part of the code again and again, let's first write down a code for swapping. Okay, simply swapping an array. So what are we given? Given an array A 1 2. Okay, that's the given data, and then we are supposed to write down an algorithm to sort this array. Okay, so let's first write down a code to swap two elements in the array. So what is the input? Input is the array itself, and then two indices I and j. Why is that? Because we are supposed to replace AI with AJ. That's why. Okay, which two indices are supposed to be swapped? That is the question. So that's given as an input, AI with AJ. So how do we do this? Well, once again, it's easy. So now you guys are familiar with how to write an algorithm. So I'll just go on writing it instead of saying too much. I'll say things that are important. Other things is sort of obvious now. Okay. So we'll start with a temporary variable t. Okay. A temporary variable t is going to be first given the value I. Okay. T gets assigned the value I, a of I. Sorry. The temporary variable gets assigned the key that is at the position I. Correct. Then we replace the value at a of I with the value at the value a of I with the value a of j. So we are replacing the value at ith position with the value at jth position. At the end of the step, at the ith position, we have the jth value. At the jth position also we have the jth value. So we have lost the value at the ith position. Okay, the value at the ith position is now stored here in the variable t, right? And now we have to put this value at the jth position. So the jth position value is now given the value that is in the variable t. Okay, so this completes this form. Take a empty space t, put the value at ith position into t. Then at the ith position, place the value at the jth position. Then at the jth position, place the value at the in that temporary box t. Okay, that completes the swap. Okay, so this was a basic operation that we will need here and there throughout. So we will stick to that. Okay. Now the second thing is this merge step that we're supposed to do. Now the merge is taking the input. The input it takes us two arrays. Okay. So in this example that we were seeing, we took them to be of the same size, 1 to n, 1 to n. We don't even need them to be of the same size. Doesn't really matter. Okay. The key point is that the inputs are two arrays and the output has size equal to the sum of the two sizes. Right. So what do we do now? So we need to create a new array. Okay, so let's create a new array which will store the merging of both of these. Okay, first thing to note is that, so let me write down as an assumption input arrays to be merged are already sorted. Okay, if you remember, we assumed that, right? Two smaller arrays are already sorted. We pass them as input to the merge function, and then the merge function merges them and gives us another new sorted array, right? So that is already assumed. Okay, so A and B are inputs to the merge function, but they are both already sorted. Is that okay? So now let's go ahead. First, what do we have to do? We need to create a new array, right? So create. So this is, I'm just using a keyword. Create means basically create the space or whatever. Okay? So create a new array C. But what is the size? 1, 2. The size is a dot length plus b dot length. Okay, so okay, I need to this further. That's all. Right? C dot length is equal to a dot length plus b dot length. Okay, 1 dot 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 up to a dot length plus b dot length. That is what we need to do. Is that okay? Now what do we? We start comparing elements from A as well as B. That's what we do. Right? So let's take 2 pointers. So it's more or less similar to what we have written here. It's just that we will write it in a more neat fashion. Okay, we'll write it in a more neat fashion. Right? So okay, so let us take 2 pointers. So we have taken P and Q. So let's take P to be equal to 1, Q to be equal to 1, R to be equal to 1. Okay, we'll stick to the same notation. P is the pointer, P is the index for A, Q is the index for B, R is the index for C, the sorted array. Okay, that is that. And now, how long do we wish to sort of continue this? Right. So we need to do some sort of this swapping thing for as long as we don't hit the boundary of at least one of the two arrays. Right. So we have written here while p less than n and q less than n. We'll do this and then we proceed. Okay. So okay. So while is just a variation of the for. While checks the value already. Okay, so it's very clear what while is. So I'm not getting too much into the finer detail. So while p is less than a dot and, or I should write it, while p is less than a dot length and q is less than b dot length. That's the condition. Okay, when both of these are true, what will I do? I will find the minimum among a of p and b of q and then put that in that particular location. Is that right? For instance, right now p is 1, q is 1. I'll compare a at 1, b at 1 and find the shorter one, smaller one and put it at c of 1. Is that okay? Right? So let's write it down. So if it's the same thing, we have already written it up. So a of p is less than b of q. What do we do? I'm not writing then because it's obvious. I'm leaving the indentation, right? I'm leaving a tab space. So it's understood that it means then. Then C of R is assigned the value A of P because you want the smaller value, right? If this is not true, sorry, this is done and then we need to shift the pointer also. Okay, so P has to move forward, if you remember, because now we need to check the next element of A after this. Okay, we don't need to look at the Pth element anymore. That is it. If not, then what does this mean? This means B of Q is less than A of Q. So then C of R is equal to B of Q, right? And then we'll shift the Q index, right? And this completes the if part. This completes the if part. And once we are done with this, what else do we do? We also need to shift R, right? C of R has been filled. So now R goes to R plus. This completes the while. Is that okay? All right. Right. Now, what is the next thing? Next thing is what happens when either P is equal to A dot length or Q is equal to B dot length. Okay, when one of these happens, this while loop will stop working. We will come out of this and then we need to write the next part. Okay, so next part is also here. We have not written it in full detail, but let's write it in full detail now. Okay, so what we know now is at the end of this loop, this keeps running again and again and again as long as P is less than A dot length, Q is less than B dot length, right? P and Q are both increasing plus one, plus one, plus one. At some point of time, one of them is going to hit the limit. The moment it hits the limit, we will stop running this. We will go out of this loop. Okay, which one hits it? That is what we need to check now. So if, let's say the first case, if P is the one that hits the limit, all right? If P is the one that hits the limit, what should we compare it with? Right? So you see, you just need to compare A of P. Okay, A of P is like the last element now of A with the first element of B. You see, you need to compare it with the first element of B. That's what we do here. Okay, so let's write it down. So there is a smaller if inside. If oh, there is a small mistake. Okay, so let me not go to this. Okay, I'll explain it again. That's good. Okay, so this is where we are. Now we are at the last element of A, and now we need to, B has some length, right? B still has possibly few elements remaining. So we need to find where to put A of P, where to place the last element of B. That is what we need to find out, right? So how do we do that? Well, we keep inserting the elements of B first, as long as it is less than 8. Okay, so I'll do this. So what is the current value of Q? That's the new thing, right? So for J equal to whatever is the value of Q right now, Q to B dot length. Is that okay? For J equal to Q to B dot length, what are we supposed to compare? We are supposed to compare B of J with A of P. So we'll compare if B of J is less than A at P, then Bj should appear before AP in the array C, right? And the current location of C is just R. So C of R is equal to B of J, followed by the next step, R equal to R plus P. Okay, and this ends it. Okay, but now more importantly, what we need to do is we don't need to keep doing this until the end. This will keep happening for as long as Bj is less than AP. But now that Bj is also sorted, so at some point of time, for some value of j, this will become greater than or equal to, and then this if will stop working. Okay, but we need that value of j. You understand? We need that value of j at which this stops working. That is the important point. Okay, so for that, I will introduce a new variable. So let's call it index, and I'll assign it as 0. Sorry, I assign it as q for now. Is that okay? I'll assign it as q. What do I do? So this runs it. Now I do a small check here. If P of j, so I rather do else. Okay. The moment this breaks, the moment Bj is greater than or equal to AP, I need to store that value. Index equal to j. That particular value. That particular value. Okay. But then after that, I don't want the loop to go ahead. So I'll do that and then I'll pass a new command. What does that say? Break for loop. What does that mean? So when index is equal to j, I'll store that value, or rather, when bj is greater than or equal to a of p, I will set the value of j in the variable index and break the for loop there. The variable j will not continue any further. I want that index. So j should not increase any further. Is that okay? So break for loop. And then the routine step. So end this and end for. Okay, so this is a new command. Break for loop means at a certain stage, if something is true, the loop should not continue. The loop should just stop and come here directly to end for. Okay, these are called break statements. There are many break statements in languages. Okay, so this is a break statement for the for loop. Is that okay? That is this. Now here's the thing. It is precisely at the index location where you need to insert a of p, right? Because bj until then was less than A of B, and you kept filling Bj, Bj, Bj at those positions, right? Now is precisely when you need to insert this element AP. Okay. So now when you break this, now what remains is C of R is equal to A at index. A of, sorry, I am so sorry. I am so sorry. C of index. Excuse me. Excuse me. C of R is equal to A of B, the new value. Okay. Once again, R is equal to R plus 1. Now I need to put the remainder values of the array B. So for J equal to index to B dot length. That's what I wanted. C of R is equal to B of J, R equal to R plus 1. And now there is nothing else. End for. Okay, so let me once again explain this. So we do the usual thing, and then we reach a point where we have reached the last element of A. Okay, and now we need to find out where to insert the last element of A, because there are still some elements remaining in the array of B. Okay, so then we go on comparing the elements of B from Q to B length. Go on comparing as long as it's less than A, the last element of A, we keep inserting the elements of B. The moment it becomes greater, we record that index. We record that index, come out of the loop and put that last value of A, right? So far we were putting the values of B. Now we put that last value of A. Okay. Now where did we stop inserting the elements of A? Exactly at the index J. So from index J onwards, we still have to continue inserting the elements of A, but after the value AP. That is what we do. Okay. So AP has been inserted. Last element of A has been inserted. And now from again index to B dot length, the remaining values we again insert into the array C. Is that okay? So there was a small mistake in what I explained here. It's not just this much, there is some more. Okay, but yeah, so go through this, and once again, if it's not clear, we can discuss it in the tutorial. All right. So are we done here? Not quite, because we started with an if, right? That has not ended. So we have ended. And now we need to do the same for the other thing also, right? The if Q is symmetric, the symmetrically equivalent other variable. So if Q is equal to B dot, right? So let me copy just Q and A, all of these things will change. So now we start with index equal to P. Okay. And for J equal to P to A dot n. So this was the exercise that I wanted you to do. If AJ is less than BQ, to do CR is equal to AJ and R equal to R plus 1. Else, we will say index equal to G and break the loop, right? And then end it. This ends the first for loop. Now comes inserting that element BQ, last element of B. Okay. Now we insert CR equal to BQ, R is equal to R plus 1. And now the remaining elements of the array 8. So for j equal to index to a dot length, cr is equal to aj plus 1. That completes the array. We will do and end if. Okay. So this was set. This was if. That completes the end. Is that okay? So this is the algorithm for merging two sorted arrays to get another larger sorted array C, whose length is equal to the sum of lengths of the two input arrays. Is that okay? Now let's go back to the main merge algorithm. So now that's easy. Now it's exactly what we have just written here. So this was it, and now let's do the C. Super. So what have we done here? Swapping, merging, merging, sorry, sorting array via merge sort algorithm. Right? So what will the algorithm be? Merge sort. The input is simply A. We have start and stop. Okay. Now it's the same thing as what we have seen here. So we just need to divide it into two parts. Is that correct? So where do we divide it? So let us say H, the halfway point is floor. So you remember floor from the previous discussion that we have seen, right? Floor of A length divided by 2. Okay, A dot length divided by 2. Whatever that index is. Or maybe I should take ceiling. Because if A dot length is just 1, if A dot length is 1, this will give me 0. Okay, I don't want to take it as 0. This is always 1. So I'll take the ceiling function, not the floor function. Okay, not much of a difference. It's just that we want to avoid 0. Okay, so I'll replace the floor here with the ceiling. Okay, so ceiling A dot length by 2. Ceiling is the largest integer greater than the number, greater than or equal to the number. Okay, therefore it can never be 0. Okay, it has to be at least. So we are safe. That is what we have. And then what do we create? We create two new arrays, right? So I've called them A1 and A2. So let me call them the same thing. So A1 is equal to, it's recursive, merge sort applied to the smaller array, right? Which one? A from 1 to H. A from 1 to H. That's A1. A2 is again what you get by applying merge sort to which array? A from H plus 1 to A dot n. Understand? That's very simple. N is A dot. So the remainder part of the array, A from H plus 1 to A dot. These two arrays are the smaller arrays obtained by sorting, and we now need to combine them, right? So what do we combine? So the combined array, I missed it right here. We need to return it as the output, right? That's the output. So we will return the output that we get by passing A1, A2 to this algorithm, right? Return merge A1, A2. Return merge A1, A2. Right? The two smaller arrays are combined, and then the merged sorted array is given as output. Okay, so that completes merge sort. the algorithm version of merge sort. Is that okay? We will look at the remaining algorithms in the next few videos. Okay, so I'll stop here.